we've already seen how to slice, filter, transform, and index Pandas data frames. To learn more advanced indexing, we need to understand what indexes are. The key building blocks in Pandas are indexes, series, and data frames. An index is a sequence of labels. Series are like one-dimensional NumPy arrays coupled to an index with fancy labels. Data frames are two-dimensional tables comprising series as columns sharing common indexes. Like the dictionary keys, Pandas indexes are immutable. Like NumPy arrays, indexes are homogeneous in data type. Let's explore all this with an example from scratch. We construct a Pandas series shares using a numerical list prices as the data. Printing shares shows a range of consecutive integers starting at 0 associated with each of the prices. Notice that the type of the series is float64, which is inferred from the numerical prices list. We now make a list days of weekday abbreviations to use as labels. We recreate the series shares, this time declaring days as the index. The new series has strings associated with its data instead of integers. We can see shares.index is of type index with data type object. We can index and slice from shares.index just as we can with Python lists. It also has a name attribute which has the value none. We assign the string weekday to the attribute shares.index.name. Now, when printing shares, that name is attached to the index. Notice an exception is raised when attempting to assign to individual index entries or index slices. Index entries are immutable, like dictionary keys. This restriction helps Pandas optimize operations on series and data frames. It is technically possible to reassign to an index by overwriting it all at once. Notice that doing so also erases the name of the index. As a larger example, we load a data frame of unemployment data from the 2010 US Census. The columns are zip codes, unemployment rates, and numbers of participants. Notice, by default, the index for the data frame contains consecutive integers starting at 0. Using the info method shows more detail. The index is in fact a range index from 0 to 33,199. This data frame, then, is indexed exactly as a NumPy array. It's better to use the zip codes column as an index instead. After all, they are identifiers for this particular dataset. We can assign the column zip to the attribute unemployment.index. Now, the index contains the zip code data, as does the column zip. We can delete the redundant column using del. The result is a data frame with only 2 columns indexed by the zip code. Printing unemployment.index shows an abbreviated index. Its name attribute is the string zip inherited from the former column. The index is itself of type int64 index and contains an unsorted list of non-consecutive integers. Looking at unemployment.columns reveals it is also an index of type object. It's worth pointing out that we could have got the index right from the start. The trick would have been to use indexcol equals zip to tell readcsv which column to use as the index. Take some time now to work on some exercises to familiarize yourself with indexes.